Hello all, this is Eric Ford, and I'm going to talk to you today for a few minutes about how to do a trend analysis. Trend analysis is important for assessing how interventions of various programs occur. In this particular example, we're going to see how an immunization program affected tetanus deaths from tetanus in Sri Lanka. And this comes directly out of a textbook by Vaney and Kaluzny called Evaluation and Decision Making. I happen to be in edition 3, I believe, and I'm looking at pages 218 and 219. I highly recommend that my students go ahead and do the practice example along with me and with the book so that you can check to make sure you've got your spreadsheets functioning properly and are getting the right output before you do your own. Typically in homeworks, I add another little wrinkle where there's either another variable included you need to have or some other feature. Nevertheless, this is pretty straightforward. The first thing I'm going to do is go ahead and I'm going to hit help, by the way, and I'm going to type in regression because we use regression the way this program is set up in order to find the effects of the intervention and the interaction of the intervention over time, because we're trying to find time trends. So I've typed in regression. Oh, sorry, I'm in my ScreenFlow variable. I'm going to Excel. Let's type in regression. And it says I can't find the analysis tool pack. This is something you may actually need to do. And you'll see here that with my version of Excel, you had to go to the website and download it. And I've actually gone ahead and done that already. And as a matter of fact, if you use a Mac, you go into Applications. And my product is called Stat Plus. And I've already opened Stat Plus. And it appears in my toolbar, which I've put my toolbar to the left here. And I'm going to need that in a minute. But the first thing I want to do is recreate the table for neonatal tetanus deaths in Sri Lanka from 1967 to 1981. This happens to be table 10.5, meaning it's in chapter 10, and it's the 5th table of the Vaney and Kaluzny text. So what do? I type in year, as they have, then year rescaled, expanded, I'm shorthanding this a little bit, immunization program, interaction, and neonatal deaths. What does neonatal mean? Neonatal means around the time of birth. In the United States, we have a fairly stringent term for this. Anything neonatal is typically within the first 6 months or even 6 months prior to partum, meaning the delivery. So neonatal is the period around death, but it varies from country to country in how they define it. Now you see these are very unattractive labels, so I'm going to go highlight those. I'm going to format these cells, and I'm going to come into the format, and I'm going to go to the alignment, and I'm going to wrap the text just by clicking that, and you see that changes my labels. I'm even going to center them, what the heck, make them look nice. So my first thing I need to do is put in my year. The first year of the study was 1967. Now I need to fill this down, and let's try a little trick here. I'm just going to go to the lower right hand corner and fill down, and notice it just copies that cell over and over. But that's not what I want. What I really want is this to advance by 1 year per row. So I'm going to go +1, plus, and then I'm going to move my cursor by arrowing up. And you'll see it highlights cell A2. And when I hit return, it gives me 1968. So now that cell is advancing. And I'm just going to go ahead and fill down. And this was supposed to go to 1981, so I've gone a little too far. I'm just going to get rid of that by deleting. And now you see I've got all my years, quick and easy. Now, it also, just looking into the table, I happen to know that the rescale starts at -10. The actual way this was set up was in 1977 was year 0. In other words, this is when the intervention actually occurred. And what I could have done is gone year 0 and then gone -1 plus the cell before. Let's see what happens if I can fill this up. Oh, that's not right. Command C. See, and it doesn't like you to do this, but it did all right. And then I can also go this way and go +1 plus the cell above. And and then I can just use my fill down trick where I pull from the bottom. And that's pretty simple, huh? Now you'll notice that in the table, if you're looking in the book, zeros, excuse me, 0 all the way across here. So that's a very important year. And by the way, there's also zeros here, 0 here. One more little trick on this fill feature. I can highlight 2 cells and fill down, and you notice I got all zeros. Now I'm going to put 1s here, and I can even just type these in. There's so few, it's not a big deal. And then I want to do 1, and then I'm going to do my little plus trick again. 1 plus the cell above. And then I can copy that cell and copy that cell by doing my fill down feature. And there you go, I've got all those. Now I'm going to do one other step that you might want to do in these analysis. Because I've created terms in here, and you can see this here in the function bar, it's 1 plus A3, so it's the cell above. So I've got an equation in all of these cells, or many of these cells here, and that's not good. So I'm going to highlight all of these cells, go to Edit, I'm going to copy, and then I'm going to do Edit again, Paste Special, and I'm going to go ahead and copy in just the values. And what does that do? Hit Escape. Now, instead of having a formula, I've just got 1969. It's not the +1 plus the cell above feature, and that'll be helpful. Now for this last set, I'm just going to have to key these in. 14 deaths per 10,000, that's what that means in Sri Lanka. 21, 16, 22.5. You can get fractions because, again, this is over 10,000 and the population of Sri Lanka is tens of millions. So these numbers are a little different than you might expect. 28, 21, 20.7, 17.5, 20.5, 20.5 again, 11, 8.5, and 4.8. Looks to me like we're actually seeing quite a lot of a drop already. Now, if I wanted to make this look pretty, again, I could go into Format, Cells, go back to my number, and I could make it, he only has one Vaney includes, and you only have one decimal place, so that's what I'll put in, and then you get the point zeros behind it. Alright, so now I've got my table set up, and by the way, lots of times when I give you the table or the information, you don't get these 3 columns of information. You have to create those yourself. I typically only give you the year and the action that's occurring in the homework, and then you have to go out and create these. So that's your task. And by the way, I may actually throw in a wrinkle where you have to create yet another cell, or there's some other mitigating variables we want to control for. And those are the wrinkles in the homework that go beyond this example. So what am I going to do? Well, I'm going to highlight these just for grins, and then I'm going to come down over here to Stat Plus, click Stat Plus, and you'll notice it changes my toolbar up above here. I'm no longer looking at the Excel toolbar, and I'm going to go to Statistics, and I'm going to do a regression, and I'm going to do a linear regression. And it's asking me for my dependent variable, and if you read through the text, you can go ahead and click here, and I'm going to click this. Notice that I'm picking up row 1 with the labels. Back to Stat Plus. Okay, it got it. Worksheet 1, Sheet 2. I'm on Sheet 2 here, and it's got the rows. And by the way, it says labels in first row is checked, so that's why I'm doing that. And then if you read the Vaney and Klusny, he says pick up columns 2, 3, and 4, and I'm doing that. He also mentions some Durbin-Watson statistics, etc. I'm not going to go ahead and take these plots. I'm just going to go OK, and we'll see what happens. Let's see what we hit preferences here, by the way. No, that's all right. So I'm just poking around, seeing what he gives me as options, and I'm going to click OK. Now it's working. Something happened. All right. And here we go. It's created a new spreadsheet for me. And I'm going to come down to the coefficients here. And I'm actually going to I'll blow this up here. Oh, I'm going to undo that. I'm going to go ahead and correct everything. Blow it up a little bit for you to 18, make it a little easier to see. All right, and coefficients, and if you look in the textbook, these are small b's, B1, B2, B3, and that's what the coefficients are. They're also called betas. That's in the textbook, it shows a beta. And here we're looking to see if our betas match up. The intercept is beta 0, and it was 21.705 in the textbook. Here it is 21.70455. So if you round off to the third decimal place, that's the same number. In parentheses, you can see the standard error. In that instance, it was 2.011. Again, we've got the same standard error. Beta 1 is year rescaled. Notice we're getting the same numbers, 0.374 and 0.339 as the standard error. Here's our immunization again. So I managed to recreate what was in the text. So I'm feeling pretty good about this at this point. And what do we learn from this? If you go over, it gives you the answer, by the way, of the statistical test. And it says that is the intercept significant? And we say yes, it is. So the intercept works. And is the interaction term significant? And in fact, it was. So that means if we look at the immunization intervention over time, it had a significant impact on deaths in Sri Lanka from tetanus. And we see it's negative, meaning that the intervention had a negative impact on deaths, which is what we want. In other words, for every death that would have occurred, we've decreased that number. So we've actually got a very nice model here. And I think that you can go ahead and do the homework and check yourself doing the same thing.